Hello, welcome to today's learning, and today we are going to learn about uh, the quadratic equations with complex roots. Generally, we have seen that quadratic equations have real roots, but today we are going to learn about those quadratic equations which have complex roots. So let's begin our class, our learning. So hello, as you can see me in this video, today we are going to learn some mathematics. So today we are going to learn about quadratic equations. Quadratic equations and with complex roots. What are roots? Roots are the solution to these equations. Like we have, let's say we have a x squared plus bx plus c equals to 0. This is an equation. On the left hand side we have a polynomial of degree 2, and on the right hand side we have 0. So this is an equation, and you can see the variable here is x, and the maximum power of x is 0 here, 1 here, and 2 here. So 2 is the maximum power of x, the variable x here. So this is a polynomial of degree 2, while a, b, c are real numbers. So a, b, c are real numbers, and the variable x has so here we see that the variable x has the maximum degree, that is 2. So this equation is going to have at most two roots. And we are going to learn about those quadratic equations which have complex roots. So these two roots here will be complex, let's say in the form of a plus bi, where a and b are real, while I equals to under root of minus 1. So this is the value of I, and I in this form becomes a complex numbers, and these complex numbers, when as roots, as solutions to these quadratic equations, we are going to learn about them. So let's see, what do we have here? Now we are going to find the roots of this equation. Ax squared plus bx plus c equals to 0, where a, b, c are real numbers, and a must not be equal to 0, otherwise the degree will not count here. The degree of 2, if a will be 0, this degree of x, that is 2, will not count, so it will become not an equation of 1 degree. Bx plus c equals to 0. Now let's solve this equation. we will transfer this c to the right hand side. It will become ax square plus bx equals to minus c, and then we will divide this equation by dividing by 2a. We will get x square by 2 plus b by, let's just see. We are not going to divide by 2a but a here, so this will be x square by, this would be x square plus b by ax equal to minus c by a. So this equation becomes like this in this form. And now to this equation we will add b by 2a whole square to both sides of this equation, the left hand side and the right hand side. So it will become something like this: x square plus b by ax plus b by 2a whole square equals to minus c by a, b plus b by 2a whole square. So look at this. This looks like a square plus b square plus 2ab. So this would become x plus b by 2a whole square. And this on the right hand side, the denominator will be the 4a square, and this would become minus 2ac plus b square, or rather 4ac. Now we will take the square root on both hand side. This will become x plus b by 2a equal to b square minus 4ac whole under root by under root of 4a square, that is 2a. Taking this b by 2a on the right hand side, x equals to minus b by 2a, this would be actually plus minus b square minus 4ac by 2a. This would be minus b plus minus root under b square minus 4ac by 2a. So this is actually the value of x here. This is the solution. This is actually two numbers, two numbers, plus and minus sign for two numbers. So let's see what do we have here. So the value x equal to minus b plus minus whole b square minus 4ac whole divided by 2a. this is actually two values. Let me just put it in this form. X equals to minus b plus b square minus 4ac by 2a, comma, minus b minus b square minus 4ac by 2a. So these are the two roots of this quadratic equation. Ax square plus bx plus c equals to 0. This quadratic equation have two roots here, and when I'll look at this quantity b square minus 4ac, this quantity b square minus 4ac whole under root, this is equal to d not this whole under, but this b square minus 4ac equals to d is called the discriminant d. So see d here, so this is actually minus b plus minus root under d by 2a, where d is the discriminant and equals to b square minus 4ac. So when this discriminant b square minus 4ac is less than 0, then something less than 0, negative under root 4ac is a complex, is actually complex. So we will get two complex roots. When this b square minus 4ac will be less than 0, this root and this root both will be complex. So we will get two complex roots for this quadratic equation in degree 2. Ax squared plus bx plus c equals to 0 has two complex roots. We have here two complex roots. Now let's see. Now we take an example of a quadratic equation. Solve 9x squared plus 10x plus 3 equals to 0. This is a quadratic equation. Now this will have the roots in form of minus b plus root under b square minus 4ac by 2a, something like this. The two roots where the discriminant is b square minus 4ac. So let's first check the discriminant here. The discriminant is b is 10, b square is 100, and minus 4ac minus 4a is 9, and c is 3. So this is equals to 108 perhaps. Yes, this is equals to 12 12 to 10 is 120, and 12 is 108. So 100 minus 108 root under is root under minus 8, which is a negative less than 0. So we will have complex roots here. Let's calculate the complex roots. Minus b is minus 10 plus root under minus 8 by 2a is 18. Minus 10 minus root under minus 8 by 2a is 18. So what is this? We can write minus 8 equals to 2 root 2i. Yes, we can write it like that. So the first root will be minus 10 plus 2 root 2i by 18 equal to minus 5 plus root 2i by 9, or minus 5 by 9 plus root 2 by 9i. So this is the first root, and the second root is minus 10 minus 2 root 2i by 18 equals minus 5 minus root 2i by 9 equals to minus 5 by 9 minus root 2 by 9i. So this is the second root. So we have the two complex roots of this quadratic equation, 9x squared plus 10x plus 3 equals to 0, which have two complex roots. The first one is this, the second one is this. So we found the two complex roots of this quadratic equation. So here we learned about those quadratic equations which have complex roots, and we derived the formula for the roots, and we found that when the discriminant is less than 0, the roots are complex. And we took an example of a complex numbers and found their quadratic equation. We took an example of a quadratic equation, this one, and we found out its roots, which are complex number, 2 roots we found out. So this was the quadratic equations with complex roots. This is done.